Have you ever considered how a single leaf or a distant chimney can dramatically impact the energy output of an entire solar power system? It is a fascinating challenge that engineers must carefully consider. Shading effects significantly influence photovoltaic, or PV, array design by reducing energy production, creating hotspots, and potentially shortening the lifespan of modules. Even partial shading on one cell can severely degrade the performance of an entire string of solar cells, necessitating thoughtful design strategies to mitigate these impacts. The core reason lies in the series connection of photovoltaic cells within a module and modules within a string. When a cell is shaded, its current output drops. Since cells in series must carry the same current, the shaded cell acts like a resistor, impeding the flow from the unshaded, productive cells. This mismatch forces the unshaded cells to operate at a suboptimal point, leading to a substantial drop in overall power output. This phenomenon occurs because the current is limited by the weakest link in the series circuit. To counteract these issues, PV array design incorporates several key strategies. The most prevalent solution involves the use of bypass diodes. These diodes are connected in parallel with groups of cells or sometimes across entire modules. When a section becomes shaded, the bypass diode activates, providing an alternative path for the current to flow around the shaded, high-resistance portion. This allows the rest of the array to continue producing power without being bottlenecked by the shaded segment. Another critical design consideration is stringing optimization. This involves arranging modules in a way that minimizes the impact of predictable shading patterns. For instance, if shading from a nearby structure occurs only at certain times of the day, designers might orient strings or even individual modules to ensure that if shading is unavoidable, it affects the fewest possible modules or activates bypass diodes efficiently without impacting entire rows. Utilizing microinverters or power optimizers on individual modules can also effectively isolate the performance of each module, preventing shading on one from affecting others. Understanding the nuanced behavior of shaded PV cells is crucial for maximizing energy harvest and system longevity. Careful placement, intelligent use of bypass diodes, and advanced power electronics like microinverters are all integral to creating resilient and efficient solar installations. This comprehensive approach ensures that even when environmental factors like shading are present, your solar array can still deliver optimal performance and a reliable return on investment.